today we're going to see some topic half adder and full adder. Full adder with logic simulator. Directly we'll go to the half adder circuit. Okay, we already know we'll go to the half adder circuit. Only circuit with the truth table we'll see. Okay, first half adder. We'll give two input and it will give some output. This considered by half adder. This two input will call by the input. Okay, the input it come from as a A. This come from as a B. This considered by the sum. This considered by the carry. For this we have to see some table. Table will directly will go and draw the table. Okay, we have the table. Files. Okay. Now the table will shift it down. Okay, we have to fixing with the value. Okay, out of it to content. Okay, so we'll give from some boldness. I understand purpose. It is the bold. I'm sorry, I'm bold. So we'll give the text A. Okay, here B. Here we have to give from as it is a carry. Then sum. So we'll fix this table with the content. Okay. Now we have in the table we record from the value 0, 0, then compromise 0, 1, then 1, 0, then 1 and 1. Okay. When you come from here, what is the process about sum and carry now? We want to add this value. So this add this value, we can write this value as suppose we have in the first two input 0, then I am having one more 0. If you want to add, result be having 0. So we having here as sum equal to 0, the carry also nothing is there, so item as 0 for here. So we can write this value is that okay, we having this 0, this also 0. Okay, when I compromise the next process, we have to take from as the input value like 0 and 1. 0 and 1 mean when performed by the addition operations become as a 1. So here I have to be as sum is 1. Then there is no carry, so give from a 0 for that. So written by the CS. So here written by the 0 then 1. Okay, after that take from as that is a value. The values come from that is a 1 0. That 1 0 also same 1. Okay, 1 in here 0 will be there. So we write from the value equal to 0 and 1. Okay, then we'll come from finally will come from as that is the final value. It become as a 1 and 1. If you want to do the process, 1 1 mean as the binary value as a 2. So I mean it's a sum is 0, carry is that is a 1. Carry is that 1. So we write from as a carry equal to 1. So we want to turn by the c comma s value come from as 1 comma 0. So write them as a 1 and 0. Okay. This compromise the half adder. What is the circuit we began now? Circuit. Okay. We have circuits are there. Circuit. Okay. Circuit. It is that. Okay. Circuit is there. Circuit is very simple. Okay. We want to draw some circuit. According to circuit only, we'll go to the next level at all. We can see the demo also. So for the circuit, we'll take the method is a gate. We want to draw the we want to draw the circuit for here. Okay, we want to write the circuit. Okay, we have in the circuit diagram. First, I have to compromise the XOR gate. So you can write that XOR gate. Okay, XOR gate with this value. Okay, okay. Then having two inputs are given. Okay, here having this one AND gate is there. AND gate. This become as a carry. This become as sum. Okay, this is going to connecting from here. This is going to connect there. Okay, 7 there is A and B as that is the input. A and B as the input, this 7 is the gate. So in this one, now we'll go to this logistics simulator will be there. The simulator will see the output. For that, we already when I open by the logistics simulator, we need to open by the JRE must be required. Java runtime compile, Java runtime environment need to JRE want to be installed. Yeah, after install that one only logistics simulator we can able to open. Otherwise, cannot possible to open. Okay. From here, you can able to explain how circuit going to be designed. Okay, first I have to compromise that is the gates. XR gate is there. Okay, we have to click here XR gate. Okay, in this one XR gate, 5 inputs are there. You can modify into the 2 input. Okay, 1 outputs are there. So right from as the like extend these 7 grid lines are the grid line. We can able to extend the grid lines. Okay. Next we are written by the one AND gate is there. AND gate have to be connect. For AND gate also you can able to modify into this is the 2 input have to be given. 2 input. This is also going to be connected. Okay, this is going to be interacting from as this one. So it have to take like okay, because some gap is there, some gap is there, can able to try it. This also give the output. Okay, now I want to get the input for the input. Having here input symbol is there. Just connecting from input from as the end. They have to be once click this input now, putting the box over there, green color lines are there. So condition be as established, and here also be as the green color line is there. This usually compromise the output pin. You give them as a one here on output pin. Here also give on output pin. So this all the condition be as properly said. But when I represent by the a comma b, first value is a b now, so I have to give the value from as the label. The label we can assign the label as that is a so this we can assign by the label a, so automatically once you move the particular pointer it is able to come to the b. A is also it is a b, so a b's are there. What it be represented here is going to be represented by the sum. Okay, we have to go outside, sum will be there. When I come from here, this something about is the carry is there. So when I want return by why want these labels are there now, I adding into one input value by here for understand purpose. I'll show you that one. Now I want to see this result is simulation. When I go to this and symbol compromise simulation, initially we having the 0 0 is there. 0 0 mean as per the table we know that what table we are representing. Table means 0 0 mean output equal to 0. So it is having the both are as a 0 only available. Suppose give the 0 comma 1. 0 comma 1 means sum equal to 0, carry is 0. When having the 1 comma 0, 1 comma zeros are there, sum is 0, carry is the desert, is having is the off. When having the 1 comma 1, only having carry will be there. For this, we can able to see do some other way to present it. Okay, instead of give by this particular value, we have to remove it. We have to adding by as a, this is a value. Look like as the input output in signals are there. You want to make the one LED over the LED. This also make them as on LED. This LED also we can able to give the name for that sum. Okay, this LED can give the name from as that is a carry, but it is not display on the particular value. It can able display on the outside the value only displayed, inside that value only going to display. Okay, we cannot possible to see the difference for that. Okay, this label cannot possible to modify inside that the LED only can able to display that one. We are not possible to increase size also because this predefined compilers are there. Why I want to give this label, that is only I explain here. When I go to the logging file, you will see here. Okay, you can able to see now three things are there. Yeah, you can see the A, B. I was given the label as the input having A comma B. Sum and carry is there. So we can able to see. I was getting one more extra inputs are there. I did not assign by any label for that. That label is there mean now. I have given as input. What is the resolution? What is the resolutions are available? S comma Y. That having 280 comma 340 place. They have to inserting by the one inputs are there. This is not required for the we remove this one. Now have to be only three things are there. You want to add A, B, then have to be a for a purpose carry and sum we added. So now I want to see the result for the table I want to generate. For the table generated, I can able to give the particular value. Now go to simulator. Okay, just you have to minimize the window. Minimize the window. Okay, here we have that is a truth table will be visible. Okay, from the truth table, first of all you want to do the simulation by here. First I have to give the value. Already the one is already available. So one mean is the carry is one. So now I want to be reset the value 0 0. So I had three inputs are taken. 0 0 mean is a 0. Okay, when I compromise the 1 0 mean every sum will be 1. So when I give the 1 1 also it is 0. So what is left out here? 0 comma 1 only left out. 0 comma 1 mean we got this value. So what is here? Sum equal to 1 0 and 0 1 mean it is a 1. Both are true, both are false become as output. Output also 0. When you having the sum, when you having the 2 or 2, then only give the carries there. This is your as the half adder circuit. Half adder circuit. Here, when I want to implement into the full adder circuit, is there. Full adder circuit will continue from here. Full adder circuit. It is very easy for here. Simply keep here. This input signal and all we can able to change. For this, we want to make this copy and I have to click by paste. Just we have to move this one. It is not moving, so we can do from the selection, remove it. Then this input and all move from our side. Okay, now this connection is removed. The label we already given, so we don't want to remove this label. Keep by here. Okay, what we'll do here now, when you want to add in by that is a full adder circuit, you want to add. What are you going to add now? You want to put this by the one more XOR gate is there. The XOR gate, please note that here, one XOR gate have to be compromised a little bit, gets be as a little bit low. Then give them as the here. That is the one input you have to give them like. Suppose here having it's one inputs are there, 5 inputs are there, modify into the 2. Okay, now this connection must be as connecting from as this particular the gate output for them, and this is have to be a we have one more thing is there, you want to adding a message AND gate, you want to give AND gate, you want to give the AND gate further. AND gate should be as the here nearby that one. So in this one also 5 inputs are there, we can modify into the 2. Okay, once modifying the 2, the first one give that is the input to the first one. Okay, we have to give the first input. The second one is there now, do you want to give them as connection between them as this one to this one. First we have to extend that one, then connection, then come from this one. Connection will be established. For this, what the inputs are will give now? We'll have to give the one more inputs are there considered by the Cin. Cin, it have to be give the label as it is the Cin. Cins are there. Now what we'll do here, we want to extend the connection. Okay, extend this connection to give this value to this sum. Okay, this extend the connection, some value will be there. Some you can click and have to be place some over there. Okay, click. Okay, just to do the connection. Otherwise, now what happened? These two AND gates are there now. So you can make this one XOR OR gate connection will be required. So you want to be here, extend that one here and this one. Yeah, here. Okay, we'll extend that one. Now we go for the OR gate is the OR gate. We connect this OR gate. Okay, in this OR gate, okay, here also 5 inputs are there. You can modify into input. It is not connected, so you can adjust that one. So you can able to connect by exactly. Once connections are done now, it will show by the green color will be the green color. If it not connections are established, it's showing by the different color will be there. Okay, this is the difference between sum and carry. Now what we'll do here, connections are established. This is also whether is a connections are established. Now if you want to assign that having the labels are there, you can give by the gate value XR. This become as the label want to be assigned, and okay, this also assigned from that is a label as it is a XR. This also will assign by the gate equal to AND. Okay, here label we want to assign by the AND. Okay, this also become as is the OR gate. Okay, here this is OR gate. Now you see by the result for this one. I was given the new input is there now. For this, what happen? I want to reset the value. Reset the value. Just click by here. All having the zeros are there. Now go to the simulator. Simulator. Previously having some values are there. Just have to remove that one. Remove that two values because already we get the input. We are not adding this value by here. So you can add this A and B and C in. Then add it done by carry, then I have to sum. Okay, and I want adding here and go to table. The table is visible now, so you can able to minimize it and zoom out. You can able to see by the all thing on the one pages. Now you can able to see here. Okay, what you can do here, 8 values are there. So go to simulator. First you have to compromise 0, 0, 0, 0, 0. Now if we have that is 6 inputs are there. 6 inputs are there for here that one. We go to the some Excel. For the full adder, we'll go to the Excel. We have that is 3 plus 2 plus 8. So we want to insert the value or border set. Then having the font is the Times New Roman. Then set with the having that is the 14. Then bold. Okay, with the center. Okay, now we assign by A, then B, C in, carry in. then carry, then sum. This one as a full adder. Full adder will give the value as the 0 comma 0 comma 0. So write from as a value, then we can by that 7 value only required. So 0 comma 0, then having 0 comma 1, then 0 comma 1 0 1 1, then 1 double 0 1 0 1 1 1, then 1 1 1. So we have it required by only this much. So we remove this one. Right? Okay. This is our XOR gate value. This is represented by the 0 1 2 like. Okay, we are required at this value is become that up to 7 8 bits are the 8-bit number. Now if you perform this one, what is the sum you can doing now? Simple addition process. Addition process mean we want to do this one. Suppose I want to take the screenshot of this one. Okay, I paste on by here. Okay, okay, I'll paste here. This one as a table. Now I can able to explain to you what happened here. This two value can add. Okay, two value you can add. What is result is there? The result want to be add from here. So what is here? 0 plus 0 means 0. 0 plus 0 means 0. So it is having the 0 comma 0. Okay. When I compromise that is the value 0 plus 0 plus addition, then I have to be what I answer to be the 0. 0 plus 1 means it is a 1. So 1 mean this compromise is CS1, there is no carry bit at all. So having that is a carry become a 0, some bit is equal to 1. So if next one is that is a 0 1, then having that is a wow, 1, then one more thing will be 0 is there. So for here is the 1 and 0 will be there. So having that is a 0 comma 1. When I compromise the 1 and 1, so 1 and 1 mean 1 and 1, we'll see here 1 and 1. 1 and 1 mean what is there? 1 and 1 is having the 1 0 now. 1 plus 1 if you want to add here, this is having this 0. The first one having the 2 is completed. Okay, now go from S3. 0 plus 1 mean as a 1. Then I have to plus with the 1 mean as 1 1 mean as the 0. Then carry is 1. The CS bit compromise the 1 comma 0. 1 comma 0. Then next if you want to compare as a 1 0, then plus with the 1 plus 0. So this is also compromise the CS bit having that is a 0 comma 0 is 0 comma 0. When I come from this is the value as a 1 0 is a 1, then plus 1 mean as it is a 0 1. So the return by the carry equal to CS bit having the 1 0. Here also 1 1 also become as a 1 1 means a 1 0 plus 0 will be added, 1 0 only come. So written by the 1 0. And adding with the 3 ones are there. 1 plus 1 mean as it is a 1 0 plus 1 mean as a 1 1. So written by the 1 comma 1. This come as the full adder. This same circuit output we can see from as the here also. Okay. In the table, okay, I minimize here. Then I have to open by the table also. By giving the 0 comma 0, it's 0 now. 0 comma 1, it becomes as a sum equal to 1. So we have to give the value. Okay, now I have it to be as a 0 comma 1 0 also sum equal to 1 carry 0. Suppose two ones are there, it becomes that is a the carry bit will be as a coming. Carry bits are coming. After that 3 is over, next you can see from as a 4. 4 mean 1 double 0 is become as it is a 1 only there. So sum will be there. So you have to be as a 1 or 1, that is also carry will be reflected. Then 110 also carry will be reflected. After there is a 110, last one is a triple one mean both are reflected. This is your table. What you see from there also you can able to see. Then you can able to save this file in the logical simulator. You can save from as the full adder. Full adder circuit you can able to save. So I want to open by some other thing. Okay, I can able to open here. Okay, what is my previous one? Now I open by some other circuit from here. One is there. Some other circuits are available. Now I want to open by the my simulator. Full adder circuit want to remove. Open that one directly. I can go to here. FA is my circuit diagram. You can open it. You can already visible is there. But this table not available. Once it is have to be close this one, simulators are available. Go and have to fetch the data. You have to do the table value one by one. Until now you want to be as adding here. You cannot.